Okay, let's look at some flame tests of some chemicals. Different compounds actually burn with a different color. And you will have noticed this if you've ever seen fireworks in your life, and you've probably seen some fireworks at some stage. The different fireworks have different chemical compounds in them that give the fireworks the different colors. So what we have here is some calcium chloride and a little nichrome wire loop. So if we just dip the wire into the calcium chloride and then put it into the flame, we'll see what sort of color calcium burns with. A nice, rather bright, intense orange color for calcium. So calcium tends to burn with this sort of reddish orange or an intense orange color. Let's see what color some other compounds burn. Here we have some copper 2 chloride. This is one of my personal favorites. It's a nice sort of Harry Potter magic green fire. So that's copper 2 chloride. Now it's the metal cations that give the color. So we have compounds. This is copper chloride. The first one was calcium chloride. In fact, lots of these are chlorides. It's not the chloride part. It's the metal cation that gives the color. Different metals burn with different colors. So this copper 2 burns with this rather nice greenish color. Sort of a bit of a greenish blue. Depends on if it's a copper 1 or a copper 2 ion. Copper 2 tends to be more green, copper 1 more blue in color. Alright, let's go for another. We have some lithium here. Lithium is also quite a nice one to observe. So we have some lithium chloride, just a little bottle of lithium chloride. But remember, it's the lithium that actually gives color to the flame. In this case, a nice pink color. Hopefully it's showing out on my phone's camera okay. Turn the lights off so hopefully we can see it a bit nice and clear. Hopefully we're seeing some pink there. Pink in the flame. Pink in the flame is from the lithium. Now I've got some strontium. Strontium and lithium actually fairly similar colors. The strontium might be a bit more intense, maybe a bit more reddy, a bit more intense crimson color. Sometimes no, that's not actually picking up any strontium. Sometimes it's hard to get enough of the solution on these little nichrome wire loops. There's no strontium in there at all. What we can do sometimes is use a paddle pop stick. Now I don't have a paddle pop stick here with me, I have a bit of a match. Trouble is in the solution, no, again, not a good result. In solution it's hard to get enough of the solution onto the wood to actually show the color. So that's an unfortunate result for the strontium. Let's try barium chloride. Another way to do flame tests is with solid compounds. You can put a little bit of the solid compound onto a paddle pop stick and insert that into the flame. It's just a different way to do it. Another way is you can have the solutions but in a spray bottle, and you could spray it upwards through the Bunsen. Of course you don't want to spray it down onto the Bunsen, you'll probably blow the Bunsen out with the spray. But you can spray it up through the flame, and that gets a good amount of the solution being burnt at the same time, so it's easier to see the colors. Now this, what have I got here? This is barium chloride. This should be, so see I saw a bit there at the bottom of the flame before it went looking all orangey, which is just from the wire itself. But the barium burns with a sort of a pale yellowy green color, and I did see a little bit towards the bottom. So there we go. That was a pale yellow or yellowy green, pale yellow green color for barium. There we go. Seeing it just briefly before I'm seeing just the orange from just the wire itself. But barium solution gives that pale sort of yellow green color to the flame. Just do one more. There, saw it there. Yep. So that's barium, nice pale yellow green color. We have some potassium chloride here. Give this one a go. This one's actually, well, sometimes it's a bit hard to see. Like I say, especially in solution. If we had solid compound, we would see it more clearly. But this potassium burns should be with a mauve or a lilac, kind of like a pale purple color. Oh, there we go. We're seeing it quite nicely there. This one worked out well. Bit of a letdown from the strontium, but this potassium is easy to see there. We're burning with a nice light purple, so a lilac or mauve in color. That one actually is working out very nicely. And staying on the wire for quite a while as well. Still seeing the purple color. So that's potassium. Burns with a nice purple flame. What else do we have here? Did calcium, barium, lithium, potassium, copper, possibly my favourite. Strontium actually is another one of my favourites. I'm a bit disappointed that it didn't work out very well because I really like the copper in sort of a greenish colour, but I like this strontium as well. Strontium, lithium and copper, my personal faves. So that's burning off some previous stuff that was on this nichrome wire. I've rinsed it off and I just burn off. We've seen some green there from copper. Alright, that's all gone. Just cool it down again and we'll try the strontium one more time. I'm really hoping to see a nice intense sort of crimson colour, but let's see what we get. No, that to me looks like barium. Alright, that pale green yellow colour says barium, doesn't it? Because we can use the colour that things burn to identify, the makeup of the compound. And when I put this in, that is a definite pale yellow green, and this to me says barium, which says that quite possibly this little bottle, which is apparently strontium chloride, I don't actually believe that. I'm going to suggest that it's actually barium chloride. Now, I do know that some of these compounds have been mixed up in the past. So, we can't see strontium, but it looks very similar to lithium, just maybe a little bit more intense of the pink crimson color. This one, the bottle says strontium. I don't believe it. I'm going to say this is actually barium chloride, because that's a very good result for the color of barium. So what's actually going on with the flame tests? Why do some metal compounds burn with different colors to other metal compounds? Well, it's all to do with the electrons in the metal ion, the metal cation. So here's a quick sketch of a very basic diagram of the Bohr model of the atom. What we have is the electrons orbiting in shells around outside the nucleus. Now, each shell corresponds to a different energy level. The first shell, closest into the nucleus, has the least energy. So if an electron were to gain energy, it can actually jump out to shells further out away from the nucleus. So when we put the metal compounds into the Bunsen flame, that's exactly what happens. The electrons literally are getting more energy and they can actually jump to a shell further out. Now, the electrons don't actually stay there. This shell further out from the nucleus is actually unstable. It's energetically unstable for the electron. So the electron tends to fall back to where it came from, what we call the ground state. The ground state is where we usually find electrons. So the electron doesn't stay there, it falls back down. But remember, it had to absorb energy to jump further out. So when it drops back down through the shells, energy gets released. And it gets released in terms of photons of light, so different colors, different wavelengths, depending on how much energy gets released. So in the case
that's on the screen right now, the electron drops back from the third shell to the second. That releases a certain amount of energy, and that energy level corresponds to the wavelength of blue light. And then it drops from the second back down to the first shell, and that releases a certain amount of energy, which corresponds to the wavelength of red light. Now, in this case, if we were burning this compound, we might see the purple color because we're getting blue and red light being emitted, and so our eyes would see the purple color. So the electrons of different metal ions will be excited to different energy levels, so different shells further out. They will also drop back to their ground state in different combinations. It may drop back, let's say, from the 7th shell straight back to the first, or it may drop from the 7th to the 5th and then the 4th, and then it might do a bigger drop down to the first shell. So the color observed is a combination of all of the different colors emitted when the electrons drop back down through the various shells. This means that for each different ion, we have a different pattern of spectral lines and different flame colors because the electrons will drop back differently through the shells.